So in our previous topic we have just started refractive index. Now we shall learn here something in detail about the refractive index. So dear student, we have taught you earlier that refractive index is denoted by mu, and it is given as speed of light. Mathematically it is given as speed of light in vacuum or air to the speed of light in medium. When we are taking ratio of speed of light in vacuum or air to the speed of light in medium, such that like it was air medium, okay, like there was air and light ray was going from this medium to another medium, normal was drawn, that medium was water over here, so it is moving from rarer to denser medium. So it is having property, it will bend towards normal, okay, it will bend towards normal. Hence refractive index, this refractive index of the second medium will be given by this formula: speed of light in vacuum or air to the speed of light in medium. That is, here medium we have chosen as water. So when we are comparing that speed of light in vacuum to the speed of medium, this refractive index is known as absolute refractive index. Okay, absolute refractive index, and it is simply given as mu is given as C by V. Absolute refractive index is given as C by V. It is given as C by V, where C is the velocity of light in vacuum or air, and V is the velocity of light in water. Hence absolute refractive index is given by this formula, okay, that C in air is having constant value 3 into 10 raised to power 8 meter per second. That is the value of C. So it may change, it is different in different media. Okay, so let's talk about if there is some another medium, instead of let there is some another medium, as we have discussed earlier, let one medium is two medias are there, let one medium is turpentine oil and another is water. Here another medium is water, okay, this is water over here. So when the ray of light was incident at that incident point, so which medium is denser here? Recall, yes, turpentine oil medium is optically denser medium here, because its refractive index is 1.47 in comparison to water, which is having refractive index 1.33. and we have learned in previous topic or previous lecture that a medium with higher refractive index is known as optically denser medium. And this ray of light is having property, when ray of light is going from denser to rare medium, it will bend away from the normal, like that. Hence if you need to calculate a refractive index of water, which is here, let it is mu2, let it this medium, instead of turpentine oil, let you are having two mediums. Now let we are having two mediums. First medium is having refractive index mu1, second is having refractive index mu2, such that mu1 is greater than mu2, means first medium is the denser medium. First medium is the denser medium, second medium is the rarer medium. So what will be the refractive index here? How we can calculate the refractive index here? So we can write down mu21. It stands for refractive index of second medium with respect to first medium. Okay, my dear student, hence this mu21 is given as mu2 by mu1. So finally here it can be, if this is the equation 1, it can be also written as mu2 mu1 may be also written in words as speed of light in first medium to speed of light in second medium. Speed of light in second medium. Speed of light in second medium. Okay. So my dear student, we can verify it with this formula. We have earlier discussed that it is C by V. Using that formula, if we are writing from equation 1, let's rewrite mu21. Let's rewrite that mu21, that is refractive index of second medium with respect to the first medium. Refractive index of second medium with respect to the first medium. What it can be written according to this star formula? How it should be written? So it should be written C by V2 divided by C by V1. Hence it comes to be V1 by V2. So this is the required formula. And this is known as relative refractive index. This is known as relative refractive index. Relative refractive index means refractive index of second medium with respect to 1. Similarly, if we want to calculate relative refractive index of, sorry, marker is not working properly, just wait. When we are talking about, similarly, when we talk about mu12, what do you mean by mu12? That is refractive index of first medium with respect to second medium. So it is going to be V2 by V1. This is all about refractive index. This is all about refractive index mathematically formulas. Now few more properties or application of refractive index are like that. You need to learn or you need to remember for concept clarity. It is like that when there are two mediums, let there is medium 1 which is having refractive index mu1, which is having mu2. In that case, when mu1 is greater than mu2, means the refractive index of first medium is greater than refractive index of the second medium. It suggests that first medium is the denser medium. So what will happen? Ray of light will bend away from the normal, depending upon the definition of refraction of light, denser to rare. Similarly, if mu1 is less than mu2, it means first medium is rarer. Okay. Hence, what will happen when ray of light travels from mu1, mu2? Let here mu1 is less than mu2. So this ray of light is going to be bent towards normal, because in that case upper medium is rarer and second medium is denser. Hence, when ray of light is going from, is there some clarity or not? Less clarity is there, but I hope you are listening carefully. Lecture is about to be finished for today. Okay, let's third case. What will happen if mu1 is equal to mu2? Means refractive index of both the medium is same. If refractive index of both the medium is same, there will be no refraction. There will be no change in the path of light. There will be no change in the path of light. Okay, dear student, these observations should be learned by you, and there is a table of refractive index on your page number 175 of your NCERT book. You need to go through once it. Okay, for example, if we talk about few refractive indexes, for example, vacuum is there. How vacuum and air are different from each other, you can learn from that. This is the refractive index of vacuum. If we talk about air, refractive index of air is this much, means very less difference is there. If we talk about ice, refractive index of ice is 1.31, and when we talk about water, so its refractive index is 1.33. Means when you are going to compare ice and water, so ice will be rarer medium, while water will be denser medium in terms of optical density. But in terms of mass density, once again, ice is the more denser in terms of mass density. But we are discussing here about light chapter, hence it will be optically more denser. Water will be optically more denser. For more comparison, to know more about the refractive indices of the different mediums, you need to visit once page number 175 of your NCERT book. Maximum I have